Good afternoon, ladies and gentlemen. We are going to talk about motors and optimization of oil viscosities. We're going to have presentations from Gazpromneft, Lubricants, and Rubbles. Let me introduce to you my co-presenter, Nikolay Doroshenko. I am N.Doroshenko. I am a business development manager at Rubbles. For those of you who don't know us, we've been incorporated in 2014. We develop AI and ML platforms. Since 2014, we have been working with the financial sector. More than 70% of biggest banks in Russia do business with us. We also work with large retail networks, and since 2018, we have been also offering our solutions to the manufacturing. What makes our solutions effective? We have a set of technologies that address a large number of tasks associated with AI and machine learning. On the right-hand side, you can see the functions that we usually support. We build data storage solutions. We create data connectors. We create all data processing infrastructure for processing, for visualization. And we have some solutions that we have been reusing broadly. I'm talking about business-specific tools. They help us to build new applications faster and deploy them over a short period of time. We have our own approach to the areas where we think AI makes sense. First of all, it has to make sense economically. It is not easy to find processes where AI would really be helpful. Usually, predictive analytics would account for a minor optimization. We have to find a regular process. In a perfect situation, the process that we would support with AI should take place on a regular basis. Then it would produce the best economic effect. And of course, we have to have sources of data. Without that, we cannot build a model. Today, Nikolay and myself are going to talk about the case that meets all these criteria. Over to you, Nikolay. Hello. Good evening, everyone, and thank you for the introduction, Jan. I am very honored to be here at this forum. Let me tell you about the case that has been mentioned already. I am going to give you a few facts to give you some background information. It won't take too long, but it will help you understand what we're talking about. Lubricants business focuses on several categories of consumers in different market segments. We offer our products for automotive market, for industrial market, for shipping industry. We have production sites that produce about 700,000 tons of product. We have 6 of them in Russia and abroad. We have one company, one plant in Serbia, one in Italy. We market our products in 86 countries. We have 700 different SKUs, different products. We want to be leaders in the industry, and with this big portfolio, we pay a lot of attention to effectiveness of our product portfolio, and we want to develop it continuously. That certainly translates into a very high workload on our R&D department. We see bigger tasks, and we see that they become more numerous. We have several locations where we have our R&D labs. There is a large number of people employed by those labs. we see that those labs must work more effectively. It's obvious that the new specs emerge in the markets more rapidly than ever before, and that impacts the life cycles of our products. They become shorter. So we have to be more focused on our return on investment numbers and on risk management. We have to see better time to market for new products. In short, the development of new recipes works in the following way. We get a feasibility study in the first place. Then we select a prototype, a recipe, based on which we make some assumptions about the components and ingredients that we are going to use. And then we improve this recipe. Of course, it does not always work the first time we try. Then we go back and we change some assumptions about the agents and components, and we develop a new recipe. There are several growth points which we see there. There are changing relations between physical and chemical properties of our products. Our ability to find the right formula quickly depends on the quality of our people. We can have up to 20 iterations of data exchange between the lab that is developing a new formula and various groups of test engineers. This takes a lot of resources. We're talking about a lot of chemicals, a lot of agents. To improve the efficiency, we put together the following assumption. We believe that the properties of the final product depend on the quality of inputs, and I must explain at once that we chose motor oils that give us the best example. We have selected a number of parameters that we use when we put together new formula. The new product's qualities depend on the inputs. We can analyze historic data, and that plays a big role. We also believe that there may be software that would help us forecast the quality of a new product, and that would reduce the workload on the product developers, on the chemists, and on the test engineers. Such a tool could also reduce the time span of development, and that is going to translate into shorter time to market. So we made this theory, and we took it to Rubbles, and now I'm going to take it back to Jan so that he explains what they do to it. So we received a lot of data, about 900 different blends. They were products that the company used to make. Each recipe could include between 4 and 20 components. The recipes were fairly unique. There were about 100 unique blends out of 900. We needed to know the physical and chemical properties of the inputs to be able to forecast the physical and chemical properties of the end product. We had some pieces of data lacking. You can see the availability of data at 100 degrees C and at minus 35 degrees C. We needed to know the viscosity properties of different blends at different combinations of temperatures. The database was not full. What we started with when we wanted to build an AI solution for this company. We first of all needed to learn the subject. We have invited people from the outside. We have outsourced some talent from a Swedish university who was an expert on the behavior of lubricants. We invited other experts as well. Here you can see a binary viscosity blending equation. This is an equation that helps to find the viscosity of a two-component blend. There are no simple formula out there, and machine learning along with AI help us quite a bit. We used bias optimization libraries, and we also used the gradient descent method to get better results. This is what we have achieved. Even an experienced chemist would usually be able to find the right recipe after 8 or 10 attempts. So we needed to create a model that would be able to forecast physical and chemical properties of a formula with a smaller number of iterations. We wanted to reduce that number to a minimum. On the right-hand side, you can see the percentage of cases when we got the right formula the first time. The model that we developed was able to offer the necessary formula with 65 to 80% probability, whereas an experienced engineer would usually have to go through 10 iterations. Here you can see the results that we have achieved, the accuracy of predictions. At the bottom you can see mean absolute error in forecasting of properties at 100 degrees C. Once that was done, we went to the next step, and I'm going to now give the floor over to Nikolay. Thanks, Jan. The task needed a lot of thorough work. We have seen positive results after the first trial. Now we are developing this product, and our in-house team is all over it. We continue to work on the next phases of this software, and as a next step, we want to focus on functional modeling. We want to create products, the properties of which are determined by basic input materials and more. We want to be able to simulate properties of a product which are determined by packages of additives. Then the next step would be when we would try to do operational simulation, when we try to see the variation of properties at the time of operation or at the time of testing. As tasks become more complex, the challenges grow too. The collaboration with Rubbles has been very beneficial for us, and it's been also good for Rubbles too. We get access to their expertise in data science. We avoided the need to reinvent the wheel. We can get hold of some well-proven solutions that other people have been using in our industry before us. This way, we get better understanding of processes, and together we can develop something that we could market to the other companies in our industry. So this would be good not just for us, it would be good for the entire lubricant industry in Russia. This is a very positive experience. We see that the knowledge that we have generated is growing, and we want to complete the second phase. We want to do it together.